Good morning to all. Myself Arul Somya, working as an assistant professor in Department of Computer Science and Engineering. So here I'm going to discuss a topic on how we fitting the logistic model in classification. So the next is logistic function sigmoid. That is here it converts the linear output values into a probability value. Like it produces a shaped curve. That is a sigmoid shaped curve. So here the logistic function is not a linear function that performs linear input into probability values. So the output is always bounded between 0 and 1. So making it suitable for probability predictions. So here the binary classification example. So this is the binary classification example which we can have a decision boundary that is class 0 or class 1. So logistic regression flow. So the flow of logistic regression is we can get the features that is x1, x2 to xn. So and then the linear model which can be a formula of sigmoid. So the next one is we can get the sigmoid value, that is a probability value we can eventually get. So model representation. So model representation in the sense in a linear equation, we can get a model representation by applying sigmoid to get the probability values. Like a equation flow from features, a linear model, sigmoid and a probability value. So what are all the benefits of graph database? So here we can get a predicted versus actual values. That is either we can get yes or no, like 1 or 0. So fitting the logistic model. So logistic model, how we can get in a regression type. So here a step-by-step procedure is given here. So first how we can understand the logistic regression. So here it is a powerful statistical method used for a binary classification. And also it uses when the target variable is binary, that is 0 or 1. And here it predicts a probability value that can be an example that belongs to a class, that we can find the best fitting a shaped curve to separate classes. So here the step one is we can collect and prepare data. So using the database, we can collect the data by using a linear equation to calculate the value. So here the formula is Z is equal to UX plus B. That is here the UX represents the weights and B is represents the bias form. And then in step 2 we can build a linear model, that is we can use a linear equation to calculate the value, and we can represent the weights and bias form in an initial value by using the by using the data set in a random way. So in step 4, we build the linear model. By using a linear equation to calculate the formula, so we can represent the values and bias form in a initial values of U and B in a often set randomly. So in step 3, we apply the linear function. That is, we can get the log loss function by graph the curve in x axis and y axis. So in step Y, we define the model. So defining the model by credit scoring. Like it is a medical diagnosis. So here in medical diagnosis, we can either the disease will be positive or negative. So using this, we can credit score will be either in x-axis or either in y-axis. So in applications of logistic regression. So application in the sense we can use a separate a data set from a linear data set using a tanning value. So we can predict the class labels and we compare the actual labels by calculating the formula. So using the directions of either x or y axis, we can access the overall performance in the model. So summary. So coming to the summary, we can get the logistic regressions in an ideal for a binary classification, and log loss effectively measures the predictions errors. And we can the key steps includes data preparation, modeling and representing, and finally the evaluation. So conclusion. So coming to the conclusion, the fitting the logistic model, it is a powerful algorithm for binary classification problems, and it converts a linear combination of features into probability using a sigmoid function. And this model is trained using log loss, which penalizes wrong predictions effectively. Thank you.